Hello and welcome to our lesson on sets, inequalities, and interval notation. This is going to be from section 1.4 from our text. Looks like we've got about, 3 concepts to cover here. We're just going to jump straight into the examples today. Number 8 to begin with. In this problem, they give us a brace. This fancy looking bracket is called a brace, and that means the set of all t. And then this vertical line that means such that negative 10 is less than t is less than or equal to 10. And then a closed brace. So with the braces, let me point those out. With the braces and the vertical bar here, this is what we call set notation. The braces indicate a set. So this would be set notation. What they want us to do is they want us to convert this into interval notation. Now, the easiest way to do that, in my opinion, is to sketch on a number line what this interval notation tells us. So what it says, if we break it down into pieces, it says, and again reading this backwards, it says t is greater than negative 10. So we would go to our number line at negative 10. Since it's strictly greater than, that means that we have an open circle, and t is greater than negative 10. Again, reading this backwards means that we're going to shade to the right because that would be greater than negative 10. And then if we look at this other piece here, this says t is less than or equal to 10. And so over here, we're going to put positive 10. This time we have less than or equal to, which would indicate a solid dot. And if t is less than or equal to 10, then that would shade to the left. Less than or equal to is to the left. And so this is the graphical representation of the set notation. From this, we can then easily get interval notation. So interval notation is always read from left to right. And the interval notation basically describes what is shaded. So the shading starts at negative 10. An open circle corresponds to a parenthesis, and then the shading stops at positive 10, and the solid dot corresponds to a bracket. And this would be the way that you would write the interval notation for the shaded part of the number line. So again, just to illustrate here, if you have set notation and you want to go to interval notation, in my opinion, it's easiest to go to the graph first as an in-between step and then to the interval notation. Let's look at another one of those, number 6. We'll back up just a bit. And this one says the set of all t such that t is greater than or equal to negative 5. So again, this is set notation. I'm going to stick with my same plan that I had before. I'm going to go from set notation to the graph and then to my interval notation. All right, so what does this set notation say? Well, it says that t is greater than or equal to negative 5. So that means on the number line at negative 5, we're going to have a solid dot because we have greater than or equal to. And it is kind of cool here in this case where you only have one inequality, that the inequality indicates the direction of shading. greater than -5 means to the right of -5. And since there is no other restriction, that's going to shade off to infinity. So now that I have the graph drawn, I can then easily get the interval notation. Remember, the interval notation is always represented from left to right. So if I scan from left to right, I can see that the shading begins at -5. The -5 will have a bracket that corresponds to a solid dot. And where does this shading stop? It doesn't. And so that means that we're going to shade off to infinity. Okay, so now another important thing is if you go to infinity, you always have a parenthesis. Got that? Infinities get parentheses, never a bracket. And if you want to know why that is, it's because a bracket says up to and including that number. But since you can never get to infinity, then you can't include that endpoint. It just keeps going. And that's why we use a parenthesis for an infinity. And that's going to do it for the first two examples, going from set notation to interval notation. Next, let's jump down to number 13. In this example, we are given a graph where it says that our shading starts at -√2. They have a parenthesis on the number line, and the shading goes to the right. The instructions say, write the interval notation for the given set or graph. Well, this is going to be even easier than number 6 and 8 because here they give me the graph, which is like the intermediate step of the previous problems. So this should be super easy because you can go from a graph to interval notation easily. I don't think I can emphasize this enough. Interval notation is always from left to right. And since they have a parenthesis on the number line, we're going to have a parenthesis. Our shading starts at -√2. That is the indicated value all the way to infinity. And that is done. Man, that was too easy. Let's do another one. How about number 14? All right, so again, we have a number line. And this time on the number line, we have an endpoint of 8. They have a bracket this time. And the shading goes to the left. So if you think about this, this would mean everything from 8, including 8, and less than 8. To the left means less than. And if we were going to write the set notation, that would kind of be important that we understand that this would be less than 8. But doing the interval notation, you just have to understand that we need to represent the shading from left to right. So where does this shading begin? Well, it begins at -infinity, because if you shade all the way to the left, you're going into the negative numbers, and that would go off to -infinity. And where does the shading stop? Well, it shades up to 8 and including 8. So the bracket on the number line corresponds to the bracket in our interval notation. And there's the answer for 14. And that's it for those examples going from a graph to interval notation. Now it's time to move on and look at number 25. In number 25 here, they give me an inequality and they want me to solve for x, solve and graph. Here we go, solving for x. An inequality works just like an equal sign. We're going to bring the -11 over, which will make it into +11. And that's going to give us x is less than or equal to 11 minus 2 is 9. So that would be the solution. If it said solve, you're done. And then to graph on the number line, it's basically 3 steps. Number line, open or solid, shading. So our critical point here is 9. Less than or equal to, since it has the equal to part, means a solid dot. And we're going to shade to the left because less than means to the left. Now, once we have our graph, really it would be easier to go ahead and do interval notation. Let's go ahead and do interval notation next. So where does the shading start on the left? Well, it starts at negative infinity. Remember, if you shade all the way to the left, you're going to negative infinity. And the shading stops at 9, and we have a bracket because that corresponds to a solid dot, which corresponds to the less than or equal to, the fact that we have the equal to part. And there's your interval notation. Now, to do the set notation, this is super easy because we already have the solution. So the set notation is going to say the set of all x such that, and then you just write this statement here. X is less than or equal to 9, and that is your set notation. And that problem is done. Let's try one more. Number 29 says 0.3x less than negative 18. This one's a little bit different because to solve for x here, we're going to have to get rid of the coefficient of x, which means we're going to have to divide both sides by 0.3. Let's see, that's going to give us x is less than. So what is negative 18 divided by 0.3? Well, I'm going to use my calculator for that. Negative 18 divided by 0.3 is negative 60. And let's put a box around that because we're done with the solution. Now to the number line, I've got my critical point. Open or solid? Well, this time it's going to be open because we don't have the less than or equal to. It's strictly less than. But since it is less than, we're going to shade to the left. And so there's the graph done. Next, the interval notation from left to right. Our shading goes from minus infinity up to negative 60. Remember, the open circle corresponds to a parenthesis, which corresponds to the strictly less than symbol. Again, that's our interval notation. And for the set notation, that's going to say the set of all x such that, and remember now you just bring down your inequality solution. X is less than negative 60. And there is your set notation. Number 41. We have 2y minus 7 is less than 5y minus 9. Here we are going to have to do a little bit of work to get y by itself. Do you see I have y's on both sides? So what I'm going to do is I'm going to bring the 5y over to get with the 2y, which means the negative 7 needs to come back to get with the negative 9. So what is that going to give me? Well, that's going to give me 2y. That'll become minus 5y less than. Negative 7 becomes positive 7 minus 9. And then we can do a little CLT, a little combine like terms. 2 minus 5 is negative 3y. 7 minus 9 is negative 2. And now notice to get y by itself, I'm going to have to divide both sides by negative 3. Warning, danger, Will Robinson. Anytime you divide an inequality by a negative number, the inequality has to flip. Did you catch that? It's because we're dividing by a negative number that causes the inequality to flip. And that's just a rule for inequalities that you need to know. All right, so now we're going to have y is greater than, negative over a negative makes a positive 2/3. And that is now solved for. So now we can go to the number line with my critical point. Open or solid? This time it's going to be open and shade to the right because greater than means to the right. Interval notation is going to be everything from 2/3 to infinity. The open circle gives us a parenthesis. Remember, infinity always gets a parenthesis. And last but not least, we're going to have the set notation. So this solution would be the set of all y such that y is greater than 2/3. Number 58 says that we've got 1/3 times 6x plus 24 minus 20 greater than negative 1/4 times 12x minus 72. And this has all the key features of a great math problem. We've got parentheses, we've got fractions, we've got an inequality. Getting excited. All right, so if I'm going to solve this for x, the first thing I need to do is get rid of the parentheses or get rid of the fractions. I can do either one of those first. And I happen to notice that if I go ahead and do the distributive property to get rid of those parentheses, it is going to get rid of the fractions too. Because what is 1/3 of 6? Well, 3 goes into 6 2 times. So that'll give us 2x. And 1/3 of 24 is 8. 3 goes into 24 8 times. Minus 20 comes down. And then negative 1/4 times 12. 4 goes into 12 3 times. So that'll be negative 3x. And then negative 1/4 times negative 72. Negative times a negative gives me a positive. 4 goes into 72 how many times? I'm not exactly sure, so let's check with the calculator. 72 divided by 4 is 18. So it does divide evenly. And that gets rid of the fractions and the parentheses. Next step, I need to get all the x's together on the same side. So I'm going to bring the negative 3x over, and the constants are going to come back. Okay, so watch what happens here. I've got my 2x comes down. My negative 3x becomes plus 3x greater than. So watch this. What is 8 minus 20? 8 minus 20 is negative 12. But if I bring it over, it'll make it positive 12. So I combined like terms and then brought it over all at one time there. And then the plus 18 comes down. And then we can do a little CLT, combine like terms. That's going to give us 5x greater than 30. Last step, divide both sides by 5. And since I'm not dividing by a negative number, the inequality gets to stay greater than. Final answer, x is greater than 6. That is now solved for. Now to the number line. I've got my critical point. Open or solid? Well, it's open and shade to the right because it's greater than. Interval notation would be everything from 6 to infinity. And then for the set notation, that's going to be the set of all x such that x is greater than 6. And we're done. And we're done with this lesson. So if you have any questions or comments, please feel free to leave those in the comment section below, or you can text me. And thanks for watching.